In today's video, we are going to look at defining congruent triangles, how to name them, and how to solve them. So we want to start out with knowing, again, what congruent triangles are. And congruent pretty much means equal, but we're looking at things a little differently. Congruent we use when we're referring to an object that's the same, versus when we use the word equal, we're looking more at the measurements of those objects. So when we're dealing with congruent triangles, these are triangles that basically have the same size and shape. In other words, same kind of triangle, like both acute triangles, both equilateral triangles, things like that. But this also means that their corresponding parts, in other words, their sides and their angles, are all congruent, or they all have equal measures. So another thing to look at for defining congruence is we might use the terminology CPCTC. And we'll look at this a little bit more when we do proofs, but that basically just stands for the abbreviation corresponding parts of congruent triangles are congruent. So if we know triangles are congruent, that means all of their sides match up and all of their angles match up. And we can actually figure out which ones are which just by giving or being given the names of those triangles. So in any congruency statement, all we're doing is matching up the pieces that are congruent. So if I look at my first triangle, triangle ABC, and you'll notice I have some sides marked congruent to the other triangle. I have angles marked congruent to the triangle. And it's important to look at what order these go through and how I use those to create my name. So on my first triangle, I'm going to go ahead and call this triangle ABC. So triangle ABC. And specifically, notice how I drew that arrow. If I'm looking at the angle specifically, I started at the single angle mark, went to the double, and went to the triple. So when I name the other triangle, I want to make sure that I'm naming in the same order. So I'm going to start at single, double, triple. Excuse me. So therefore, our triangle ABC is congruent to our triangle DEF. And then we can also match up all our sides and all of our angles. So we could say that angle A is congruent to angle D, angle B congruent to angle E, angle C congruent to angle F. And you'll notice those are all in the same order in the names as well. We could also look at our sides. So segment AB or side AB, it's in the same place as DE in the name, so I know they have to be congruent. They also have exactly the same number of dash marks on them on the diagram to show that they're congruent. So we could also say side BC is congruent to side EF, and side AC or CA, it doesn't matter what order. But we do need to make sure we go in the same order in the name. So if I go A to C, I need to go D to F. Alrighty, so let's look at a couple more diagrams. So in our first example, again, notice I have not given you a diagram. We're going to do this just based on the names. So for our angles, for example, I might say that angle J is congruent to angle P. I could also even use 3-letter names on here. I could say angle KJL. So let's go in the same order on the second name. So we're going to go angle QPR. Or I could say angle L is congruent to angle R. Again, all different ways to name these angles. Actually, I didn't name all of the angle pairs. Did you notice anything between the first and the second ones that I labeled or that I listed out? Those middle letters match up with the same angle. So I actually listed the same angle twice. It's okay, it's not giving all the congruent sides, so I should probably put in the other set. See, the one that I didn't match up was angle K is congruent to angle Q. Okay, for my sides, JK is congruent to PQ. Again, I'm just going in order, so KL is congruent to QR. And then we could also do JL is congruent to PR. Okay, writing another valid congruency statement is really just what other order could we name the triangles in? So if I switched around my order for my first triangle and maybe I did KJL, kind of like I did with the angles, I would have to switch the order of my triangle vertices, the points that I'm using to name, in that same way. So JKL would be triangle QPR. Alrighty, then let's try out number 2. Actually, go ahead, pause the video and try this one out on your own, and then see how your solutions, how your answers compare with mine. Okay, here we go. So again, multiple ways to do out the angles. I'm just going to go ahead for time's sake and label out with the single letters. Oops, there we go. Let's try that again. So angle X congruent to angle F, angle Y congruent to angle G. Again, if you use 3 letters for your names, just make sure that those show up in the center of your name, that middle letter, and you're still naming the same angles. In terms of sides, we could do WX congruent to EF, or we could do XY congruent to FG, or WY congruent to EG. Again, another valid congruency statement, just reordering our letters. So maybe I could do triangle YXW. All I did was reverse my order, so do the same reversal, GFE. Now, looking at these orders, using these names, it actually helps us match up more pieces. And 2, looking at number 3, you'll notice, I gave you the names and I gave you triangles, but they're kind of twisted around on each other. So I could, if I want to, relate to specifically to the diagram, but again, since they're twisted around, I might actually just use the name to help me out on those. So number 3, we're given that KPM is congruent to AYC, my 2 triangles. So if I just match up with my letters, KM from the first triangle matches up with AC from the second. CY, again, same order, would be MP. PK, back with the first one, would be YA. So I'm always twisting around in exactly the same order as whatever they gave me. Angle Y from the second triangle would be equal to or congruent to angle P. Angle K should match up with angle A. And ACY, so again, I went A, C, and then back to Y. I need to go in the same order. So K, M, back to P. K, M, P. G and H are just extra congruency statements, again, playing around with our order. So MPK just went backwards. So that means I need to do triangle CYA. Or if I have triangle YAC, again, middle, front, back, I need to go middle P, front K, back M. All right, so the other thing that we can do with this is we can actually use this to solve out triangle pieces. And again, sometimes the triangles may be drawn so everything visually matches up, but sometimes it's going to be twisted around and we need to rely on other cues like the names or the marks on the triangle to help us out. So let's see, example 4. So we're given that GHJ and triangle XYZ are congruent. So I already have some marks going on with these diagrams, but let me do some extra labeling just to make sure. So we have HG, 27 feet. So I know I can go ahead and label that as 27 as well, because they are isosceles triangles. Wait a second. Well, the first one's an isosceles triangle. If the triangles are congruent, then the other one must be isosceles as well. And I just need to make sure I match them up. So segment GH, well, that's the same as XY. So I can label that as 27. And HJ is the same as YZ. So he's also 27. Okay, then that means our remaining segment ZX, our 18 feet, is the same as GJ. I also have an angle in there. So angle Y, same place as angle H, so that's 38 degrees. And then we can actually go ahead and find our leftovers. Because these are isosceles triangles, I know the 2 base angles have to be congruent to each other. So I just have to find my leftover from 180 degrees. So take 180, take away your 38, and that is going to give us 180 minus 38 gives us 142. And so half of that, I believe, is going to be 71. Yep, 71 degrees. So we know that each one of our angles is 71 degrees at the bases. and then 71 degrees up on this one. So now actually I don't have to do any real work to figure out my solutions. All I have to do is read off of the diagram. So GJ we labeled as 18 feet, XY we labeled as 27 feet, and ZY also 27 feet. Angle H we found was 38 degrees, angle Z is 71 degrees, and J was 71 degrees. Alrighty, so in number 5, we're up in the ante a little bit. Not just straight out measures, we've got some expressions in here to work with. So we are given that UVW, triangle UVW is congruent to triangle TSR. We need to solve for X, Y, and Z. And we cannot put all 3 of those in the same problem. So I'm going to focus on one at a time. So my first one, my X. And again, I could pick any one that I want, but specifically, he is on segment UV. So if I look at the names, I know that segment UV has to be congruent to segment TS. And so TS is labeled with a 53. So I just have to set those equal. So 12x minus 7 equals 53. Add your 7 to both sides. We're looking at a 60. And so x equals, I believe that is 5. So there's our answer for x. Alrighty, so let's check out our y. So here's our y segment, RS. So in the same order in the other triangle, I know that RS has to be congruent to WV. And so WV on the other triangle is 57. So we can do 5y minus 33 equals 57. So add a 33 to both sides. And I believe we're looking at a 90. Never a bad idea to check your math. Divide both sides by 5, and that will give you 18. There's our y. We can do the same thing with the x. Alrighty, so our x, excuse me, our z is sitting on segment UW. So looking at the same order, we're looking for segment TR. So UW we know is congruent to TR. So we just set them equal. So UW is 3z plus 14. TR is 50. Subtract the 14 from both sides. So we're looking at 36 and divide both sides by 3 to get 12. Alrighty, go ahead and pause the video and try doing the same thing on number 6. And match things up with your name and then set them equal. Okay, let's see how things went. So again, we have an X, Y, and Z. On this one, though, we're looking at angles. So we just have to be careful of which ones we're picking out. So let me start with X. So my X angle, well, that's labeling our H. So our H is in exactly the same place as N in the other name. So that means that those 2 angles need to be congruent, and we just set them equal. So 6x minus 29 equals 115. Add a 29 to both sides. We get 6x equals 144. And I definitely need to get my calculator out for that one. 144 divided by 6 comes out to be 24. Alrighty, next one. Let's look for our y. So our y is in angle F, which means we're looking at angle S. Except we don't know that information yet. So I actually have to pause here and think about, well, what extra information do I have? I know that in the left-hand triangle, I've got angle P is 36. I know angle N was the same thing as angle H, so that was 115. Let me go back to blue. So that was 115. And what do we know about the sum of all the angles in a triangle? Well, they always have to add up to 180 degrees. So that means to be able to solve out for angle S, I just need to subtract from 180. So 180, take away the 115, take away the 36. And again, using the handy dandy calculator, 29 degrees, which it makes sense with the diagram. That's a smaller angle, so we've got a smaller number. Awesome. Now I can set these things equal to each other. So 3y minus 1 equals 29. Add your 1 to both sides, we get a 30. And so y is 10. So now let's do our last one, our z expression. So z, that's sitting on angle C. Angle C is in the same spot as angle P. So that means those two can be set equal. So 4z minus 32 equals 36. Add 32 to both sides. We're looking at a 68. And divide through 68 divided by 4. That gives me a 17. Alrighty, if you do not have a diagram given to you in the problem, just need to draw one. And actually, we could probably get away sometimes without drawing the diagram, but I always like to start with that because we might have that same kind of scenario like we just did in number 6, where we're given almost enough information, but we need to pause and do a little extra math to figure out any missing angles. So let's see what they gave us. So we have triangle QRS, and I'm going to go ahead and draw them in order just to help myself out. And triangle MNP. Okay, we are given the information segment QR is 11, QS is 15, and MP is 2x plus 1. So right off the bat, I know I'll be able to set those two equal when I'm ready to solve. Okay, we also, now they started giving me angles. I'm going to switch over to red. So angle S is 84 degrees. Angle R is 32 degrees. And angle M, not quite enough room, 17y minus 4 degrees. So that goes in the corner. And so I'm noticing M is in the same spot as Q would be. So I'm going to go ahead and do that now. If I knew what angle Q measure was, I'd be good to go. And I just need to subtract from 180. So 180, take away the 34, take away the 84. That whole thing comes out to be minus 34 minus 84, 62 degrees. So we now know everything we need to be able to solve these out. So our first thing that we labeled, that's what I'm going to start with. Our segments MP and QS are congruent. So I know their measures are equal. MP was 2x plus 1 and QS was 15. Subtract a 2 from both sides gives me a 14. Therefore, x is 7. And then we can do the same thing now with our angles. We know that angle Q was congruent to angle M, matches up in the names and the way we drew our diagram. And so we can just say that 62 degrees equals 17y minus 4. Doesn't really matter what side you put the variable on, as long as we get the variable by itself when we solve. So add a 4 to both sides, that gives us a 66. And yeah, this one probably isn't going to come out nicely, but that's okay. We can get decimals and fractions. And so y is approximately equal to 3.88. And again, just double checking my math really quick. Did you find my error? So I did have a quick error. I copied down 34 instead of 32. So let me go back and fix my math a little bit. So that means we weren't dealing with 62 here. We are going to have to fix this piece and this piece. And that means our answer for y will change. Okay, so 180, take away 32 and 84. That actually gives us a 64. So let's update everything. So now when I add a 4, I get a 68, 64, right? Yep. So I still might not get the prettiest answer, but let's see what happens. So 68 divided by 17, hey, that comes out really nice. That comes out as a 4 now. So again, decimal answers aren't necessarily incorrect, but if you weren't expecting one in that scenario, never a bad thing to go back, check your math. Alrighty, as always, watch any examples you need to over again or pop into Zoom and let me know if you have any questions.